I'm Rochna Dhand, and I'm here to just introduce really quickly what HPE InfoSight AIOps is all about. And then I think the more interesting part of this presentation will be when David Adamson, our chief data scientist, goes into some very specific scenarios of at the heart of our AIOps. So I'll just do a very quick introduction. I know many people here are actually familiar with InfoSight already, and so I did not want to spend too much time on it, except to just give a very high-level intro as soon as my slide can advance. Here we go. So really, HPE InfoSight is an AIOps platform in the cloud that collects telemetry and other data from our install base, mostly from HPE infrastructure, but also the workloads that run on top of the infrastructure. We have prioritized VMware and Hyper-V as those first workloads, and we'll be doing other workloads in the near future. And so we collect telemetry data, that is performance information, but also other information such as configurations, logs, events, information, etc., from across our install base. It comes into our HPE cloud in a secure way, where we run analytics on it, and we'll go into more example of what those are. And so there's multiple parts into InfoSight. When the data comes in, we have an automation engine which has our fingerprints, which is a result of lots of AI models, some of which David will go into, that are able to detect, when an issue can happen. The data that comes in is scanned against this set of fingerprints that we have created to see if something might go wrong in a customer's environment. Whether it's performance related or configuration related or even just wellness information. If there is something that we see that might go wrong in the future, we are able to automatically open a support case for the customer, bring it on their radar, bring it on our radar. And not just that, we're actually able to recommend solutions to customers, very precise, actionable solutions in many cases, to say, how do you fix a problem? And then in very few sliver of a use case so far, we're actually able to fix the problem, but we'll do more of that in the future. And so the data comes in, it gets scanned against this install base. We do a lot of processing. Like I said, David will go into that, all our models that then go back to solving various use cases, such as performance, predicting future performance issue, doing root cause analysis for existing performance issues, detecting misconfigurations, taking many variables into account in the environment, for example. The customer actually experiences InfoSight through a portal. They log into a cloud portal, and where they can actually see what's going on with the environment, see our predictions, our recommendations across the base, for capacity, performance, etc. And there is nothing to install on the local install base. HPE InfoSight started with nimble storage, as was pointed out earlier here, but that capability now has come to the 3-part line, the primary storage line, SimpliVity, etc., ProLiant servers. Our vision is to provide this AIOps-based management to the entire portfolio of products. But really what key is in making this effective in terms of detecting and preventing very hairy issues is to have a great volume of data, as well as a variety of that data. And so lots of different, hundreds of thousands of different customer environments is where we learn from. And each environment is unique in its own way. We have a lot of support information. And so the fact that we are global and in the cloud, and we collect data from across different environments, and a lot of it, is very key to the variety of problems we can solve and the accuracy with which we can solve them. So like I mentioned, this is started with Nimble storage, but now across the entire install base, the goal is to bring it to the rest of the HP portfolio. And not just that, a lot of awareness of the workloads that run on top of the infrastructure, right? Because at the end of the day, your customers cares mostly about the business application. The tiers of software and hardware that go under that business application are really just a means to an end, and sometimes a necessary evil from the IT departments or the business application owner's perspective.
So can I interrupt you with a question?
Yes.
Because so there's HPE InfoSight, which, as you said, emanates from from the Nimble acquisition, and it seems to be tied to storage servers, as you say. Is it also looking into that part which Jose was describing before as well, or are these two different products which are going to front end with something which is going to communicate with systems of record in organization, ServiceNow and these kind of things?
Right. So yes, there will be integration. We are actually very close to releasing a ServiceNow integration, because for the customer's perspective, they have their chosen panes of glass and they have their chosen tools that they have operationalized on, and so we like to exist in those tools. And so those integrations will happen. But within the company itself, you're right, this is focused on storage and servers today, but we are talking with the Aruba team as well, so that from a customer's perspective, this can be one holistic experience, as well as we as teams can learn from each other. Our models are separate, and sometimes they're unique to our unique problem domains, but sometimes, some of the anomaly detection models, for example, can be the same across the board. And so we are looking to integrate with each other.
I saw in a previous presentation as well, in your last slide, it looks like you're pulling in the config data from all the devices and stuff. So is that still structured, or do you infuse both semi-structured as well as unstructured data?
So for some of the details, actually, I want to pass on to David as well. But log files come in their structure, and because these are our products, we understand exactly what the structure there is. We've seen the structure before.
Yep.
The telemetry and the counter information, also counters that we have put in, so we understand the structure of those capabilities before already. And that also allows us to go into, because we understand not just the structure, the semantics of the data, it allows us to go into great depths because of that, as compared to our customers try some, off-the-shelf capabilities. I won't name names, but there's a lot of capabilities that claim AIOps today, but they cannot go into the level of depth and understand the behaviors of the entities they're monitoring to the extent that we can, because we do it for products that we have built ourselves. So I really want to hand it off to David without much ado, but David will go into a specific area of the modeling that we do to solve problems for customers in a meaningful way, right? Anybody can set a threshold when they're doing monitoring, or set a wellness alarm and say when a disk breaks, inform me. But AIOps is well beyond that, with being able to add context to the problems, and with the understanding of the context, be able to recommend very specific solutions and problem resolutions.
Yeah, so what I wanted to cover today is a little bit about our contextual insights sort of effort. So first I wanted to talk about the specific problems that we're aiming to address with this effort, as well as sort of why we've come up with the name Contextual Insights. Additionally, I think more the meat potatoes of the presentation is, how is machine learning sort of something that we apply to this project? And in particular, why is peer training in the cloud so essential for these contextual insights? And this, I think, will fit well with our previous presentation. See if I can advance my slide here. So first, just focusing on the problems that we address. I think typical issues that things like AIOps solutions try to address are things like alarm fatigue, right? If we have too many alarms, then people are going to ignore them because they're too abundant and not informative. Dashboard fatigue is kind of a similar thing. If I sort of configure a million dashboards in Grafana to try to monitor all of the pieces of my infrastructure, then I'm going to be looking at dashboards all day and not getting a lot out of that. So those are sort of the sort of more frequently understood challenges that AIOps supports. But I think there's also these two main key components that I want to focus on today, which are this notion of untrustworthy alarms that Rochna alluded to. If you're dealing with scenarios where you're setting naive thresholds that don't really understand the context of the data that you're monitoring, then you're not going to really be getting a lot of value out of that infrastructure and that alarm setup that you're using. So there's a lot of value to be gained by scanning the install base of users and really understanding that context when we design more dynamic thresholds and whatnot for reacting to problems. Similarly, when we're talking about making insights actionable, what we really want to be doing is we want to make sure that we're providing enough information, enough context in the report, the analysis, the notifications that we're providing to make sure that next steps are understood and known and that people have the context to go forward. So, yelling anomaly in a credit dashboard is not a useful thing for people to react to. You need to be able to actually tell them sufficient information to make that actionable, make that notification stand alone. So that goes into why we call it contextual insights, right? It's really it's a feature set that is both context driven, where we prioritize and consolidate notifications, but also make sure that all of the notifications that we're providing are informed by the normal and abnormal behavior that we've learned across all of the customers that we've observed in our InfoSight data collection. Similarly, in addition to being context driven, we're also context providing, right? We provide the narrative of the scenario. We explicitly describe problems, the diagnoses, the recommended next steps, and we go so far as to try to make sure that we, whenever possible, provide supporting information that makes, if there's a choice to be made between which recommendations to follow, we provide the context needed to make sure that people can make those decisions in an informed way. We also, to make sure that we maintain credibility and that we that we're really identifying, hold ourselves accountable for when we can and cannot root cause issues. We explicitly say when we do and do not identify the root cause of an issue. There are some situations that we've discovered in our install base where, for example, the root cause is just not knowable based on the data we currently collect, and we have to go back and add sensors and add metrics to sort of cover those use cases. We make that explicit in our product to make sure that people know when they will need to actually reach out to support to get that additional information. So speaking of some specific, go ahead.
This is Jim Jones. I've got a question. So I've long been a customer of yours using InfoSight, and it has always been really great at doing the insights, exactly what you're talking about, and making it actionable in the sense that I get a notification or your support gets a heads up and things like that. Where are we at in the journey of making that an automated thing? So for example, data store LUN is getting full, it nags me, but eventually it resizes itself up as long as there's capability, and then, makes me pull back if I need to.
Mm-hmm. It's a great question. I think, in terms of the journey in terms of adding hooks to other software products that we can plug into and whatnot, I think we're still in earlier days than we really want to be. But, so where we've made a lot of progress has been in sort of taking the feedback from the models that we've had to train and the insights that we've gained from supporting our own products and sort of making sure that our own products are as robust as possible. That's where the sort of feedback loop has been the strongest. But I think our ambitions are to extend our hooks into additional products more and more as we go forward. So we do have those ambitions, but and so while we monitor products that are not our own, and I'll go into some of that as well, we don't necessarily automate on that level.
Got a related question.
Yes.
You talked about the thresholding may not be the same for all customers. And so do you have an option based on monitoring a specific customer's environment to do a dynamic thresholding for specific customers?
Right. So a lot of the context that we build up about our a lot of the work that we've done so far has been mostly focused on the sort of peer learning. So in terms of dynamic thresholdings, we're looking at the possibility of setting up explicit feedback loops that sort of respond to users saying, I care about these alerts, I care less about these alerts. We haven't finished those parts of the project yet. Most of what we've done so far has been more of the peer learning focused and understanding how to contextualize our measurements based upon the group as a whole, if that makes sense. So it's not a lot of curation to the individual learning the behavior of specific site instances, but more that collective inference, if that makes sense. We are looking at those capabilities, but in terms of support priority, that's been those peer learnings have been front and center. So moving ahead, I wanted to provide some concrete examples of the recommendations that we provide for our end users, right? So in providing the narrative, this is an example, a screenshot from our UI. This customer, we explicitly state the problem. They're experiencing elevated write latency. We explicitly state the diagnosis, right? CPU saturation is the cause, and we go into proposed solutions. In those proposed solutions, we have configuration changes, workload management changes, as well as hardware upgrades. We don't always want to just lead with the upsell. And we, in addition to that, also want to make sure that we provide the user the context to make sure that they can make the decision between those recommendations appropriately, right? So by focusing and saying, because we know this is a CPU saturation issue, we can go in and say, what are the top consumers of CPU utilization, right? So that additional context is critical in helping people decide, oh, those volumes are the most essential aspects of my infrastructure. I need to make sure that I prioritize them and give them all the resources they needed versus, why is, my new developer running jobs that are taking all of my resources? Maybe I need to add some throttling or go figure out what the reason for that is. It's probably not something that I need to be spending all those resources on. Similarly, or to expand on that supporting information is contextualized based on the problems that we see, right? So I guess this kind of dovetails with that previous question is, while we may not be tailoring the models to each individual customer, we absolutely tailor the expression of the problems that we're seeing and the narrative that we tell about those problems, if that makes sense. So we go in and we say, if we're experiencing a CPU saturation issue, we're going to be telling you all about what are the top consumers of your CPU utilization. Similar for other resources. And for misconfiguration issues, we're going to be highlighting the volumes that we believe are misconfigured and giving you additional information and context as to what we think you should be changing. So that storytelling is really front and center to what we've been focusing on as how we personalize the experience of using these tools.
So if you do offer such a personalized information, do you offer just a diagnostic on that information, or you also provide, like some other AIOps vendors provide, something like a capacity planning or into the future? Meaning, suppose if you're looking at a certain thing based on the trend or a combination, both historical and real-time data, do you offer capacity planning metrics as well?
Absolutely, we do. So I don't have some material on that in this deck, but we do have basically sort of what-if planning tools called our Resource Planner, which allows you to go in and perform sort of sizing analysis based upon existing workloads that you have, as well as workloads that you may be planning to create. So that's another sort of avenue that I'm actually not touching on this slide, where peer learning is powerful, because we can look, when someone's sort of defining a greenfield, a new workload that they want to deploy somewhere, we can look across our install base and say, we know what Exchange looks like when people deploy it. We know what SQL Server, we know what all these different applications, VDI, whatever it is. We know the sort of workload footprint of those different applications. And so when people want to create new instances of them, we can use that information to help model that appropriately and perform those sizings. So
I would absolutely love to talk to you separately on that. Definitely.
Absolutely. Sounds great. The final point I wanted to make on sort of these personalized recommendations is, we go beyond just our storage products in this space, because as Rochna pointed out, it's very important to sort of go up the stack and get a picture of what are the pieces of infrastructure, what are the virtualization layer and what are the applications that people are actually running on these devices? How are they performing? How are they reacting to what's going on beneath them? And so we've with vEnvision and the recommendations that we've added to that capability, we have the ability to point out noisy neighbor scenarios between VMs when things are misconfigured. And we're constantly looking for new ways to expand the scope of contextual insights to cover more than just the HPE product line, so that we have a sort of full perspective of what's running and how it's behaving. So I think the meat and potatoes of the presentation is, how is machine learning applied to contextual insights? I want to go into sort of 3 specific use cases how we use machine learning to make sure that contextual insights is successful in making the correct recommendations. So first, differentiating performance or other problems versus typical behavior. We actually surprised ourselves a little bit in how tricky it is to actually differentiate between a problem state versus a non-problem state in some cases. So I'll go into that. Additionally, triaging, understanding the root cause among several common causes. That's a set of models that we also train on the install base and that are very powerful, very useful to us. Last but not least, rare conditions that people can spend a lot of time trying to diagnose because there's, it's usually the last thing you look for. How do we use machine learning models to help those targeted use cases? We'll go into that as well. So I'll go into each of these 3 situations, specifically highlighting why peer training in the cloud, where you're looking at that ensemble of users as a whole, is very powerful for solving these 3 use cases, right? So first one, differentiating problems from typical behavior. And I'm going to try and give examples from sort of the healthcare vertical to understand, to try to help understand the problem that we're trying to solve here, right? So for example, if I'm looking at heart rate and I'm trying to sort of just set a naive threshold to say, what is good versus bad heart rate, that's not really going to work because it's not contextualized, right? So if I'm, sitting on the couch all day versus I've just run a marathon, I'm going to get very different answers as to whether that's a reasonable heart rate to be having, right? Similarly, we have the same kind of problem if we're looking at, the latency measurements from a storage array. If we're looking at storage latency measurements based upon I/O sizes that are in the several hundred kilobytes versus, 4K transactional I/O, those latencies are not really comparable. So even identifying whether or not a storage device is actually experiencing a problem from a latency perspective, from a throughput perspective, those things have to be contextualized with respect to, the actual workload that they're running. And, if we asked, the developer of the product, well, what is good latency at 4K? What is good latency at, 28K, whatever different op sizes that people are considering, they're not going to know that, right? This is the kind of thing that we only learn by observation, and we're not going to learn it by observation of a few individual systems, right? We have to get a representative understanding of how this behavior works, and to do that, we have to have this sort of collective perspective. And this is one of the example functions, just a overview of it, of the kinds of things that we learn from the install base to sort of make that data actionable. And what we've seen is that, when we actually go in and try to compare this to when customers call in about performance problems and say, what if I tried to predict that based on latency versus predict that based on sort of these derived corrected metrics that we've learned from the install base, we get much, much more predictive power, 5 or 10 times the predictive power of just the raw metrics themselves.
A related question on that. You said, you wouldn't know that until you put that into production. So the baselining, how long do you take to baseline some things performance, and how constantly do you update that baseline?
Right. So what's nice about, for example, the model that I just described, because it's sort of this pure learning model, it's not something that we have to baseline for each new customer, right? So it's something that we can learn on the collective whole and apply to each new customer as they come online. So we're sort of pulling the new customer up by everyone else's bootstraps, if you will. There's a lot of, if you're trying to baseline a new individual customer based on their own data, look for what's anomalous in their context, that will require some sort of cold start time. And so that's not what we're focusing on with these models, if that makes sense. So additionally, if we're looking to sort of triage the root cause of problems, so now that we've identified there's a problem, we want to understand why. How do we go into that? So, this is another, to go into another healthcare example, if I'm, just got some blood work back, I've got all these metrics. Often when you get those reports, you'll actually see sort of the normal range of patients listed for each of those different metrics because, they don't mean anything to the layperson. How do the doctors actually go about getting those ranges, and how do we get something that's higher resolution than just sort of a ballpark range? So those information is only gathered by looking across a large population of patients, right? You're not going to be able to learn what's a normal range for these blood work measurements just by looking at a few people. Similarly, for our contextual insights use cases, we need to understand what is sort of the CPU utilization on the system, the cache utilization on the system, drive bandwidth utilization on the system, all these different dimensions of utilization. How do they sort of impact performance? Understanding those relationships is again something that we're only going to understand representatively by looking at the holistic set of users as a collective. And so those are the kinds of models that we train to make sure that we are providing the best possible recommendation for users and telling them to target which resource bottlenecks they may be experiencing in a properly prioritized way.
So David, you mentioned you train these things, and there's various ways of training machine learning models and so on. A lot of what you're talking about, and particularly with the health example, seems to be essentially just science. This is how we do research to understand how physics works or how a certain drug affects a given population of people. Is that the approach that you're taking? You kind of do science, learn things about, oh, okay, that's how this works, and then the humans discover that and bake it into the models? Or is this sort of semi-supervised or unsupervised learning and the machines figure this out for you?
Right, so I think there's, I think in terms of applied machine learning, there's always an interesting balance between how do you bring to bear sort of the expert knowledge that people have about systems that you're working with in conjunction with the data itself, right? So, and I think that's what we try to sort of maximize with our approach in kind of what you're talking about. You're right, there's some sort of knowledge that we bring to the table in terms of, expecting, there's this bank of metrics that I've got that I know are related to, CPU utilization and that kind of bottleneck. But so that is knowledge that I can bring to the table in helping me solve the issue. But in understanding what the relationships are between having a performance issue and this resource bottleneck versus that resource bottleneck and whatnot, making those sort of quantitative decisions, that's the kind of context that we're only going to be able to gather by training these models, right? So it's the unification of the context that we bring to the table, the expert knowledge, with training the models to solve the quantitative portion of that problem. That's how we sort of get maximize the value of the whole result. Does that answer your question a bit? We are trying to bring what we know to the table. So there's to some extent that sort of doing.
Yeah, I think that does. So there is some human judgment being overlaid over the computers, because computers can vary, depending on the model inputs, they can make hilariously terrible results come out of it. So there is some human oversight required to figure that out. And a lot of it can be, some machine learning models, there's a really, really complicated way to do something, which is just, this is just linear regression. We can figure that out. And then we know how to do that with a really, really simple model that actually gives us as good a result. We don't need to send a computer off to self-train itself on something that we can just teach it.
Absolutely. I think to speak to that point, whenever you're designing sort of a machine learning model to solve a problem, you're always worried about where do I land on the complexity curve, right? Do I want to pick a simple model for this use case, or do I need a model with, 1 million parameters in it versus one with 10? And, the judgment call on that is partially related to how much you trust the data that you've got, how much of it you have, as well as how much of these additional constraints you need to sort of put on it. So, for example, one of the things that I think is very powerful to be able to do when we're training these models is to bring information like, I know this should be a monotonic relationship. or I know this should be, should have concavity, or like you search for ways to give yourselves machine learning model frameworks that allow you to apply the knowledge that you bring to the table in such a way that doesn't limit the model's ability to perform its job, but make sure that it remains interpretable and actionable, and isn't going to say that, some ridiculous relationship like, well, if I'm at 75% utilization for CPU, then I'm 60% probable to have a problem. But if I'm a little bit higher, then I'm less likely to have a problem. Like, that doesn't make any sense, right? So you need to be able to make sure that we're training the models in such a way that we apply the constraints that we know to be true, to make sure that if we're dealing with a region of the install base data set that is sparse, that we don't make invalid fits on that region. So those are important constraints that we have to apply, and sort of, that's how we apply our expertise, subject matter expertise, to the problems at hand.